Hi everyone, welcome to the talk on Mobius. My name is Karthik. I'm in the Mobius team in the Shared Data Platform group at Microsoft. So today's session is an introductory talk on Mobius, the C# binding for Spark. I wanted to start with sharing a quick background on what prompted us to start the Mobius project. So as I mentioned, I'm in the Shared Data Platform group at Microsoft, and we build platform for other teams to build the data processing pipelines. And sometimes we also partner with other teams in bringing in new technologies or trying out new stuff. So one of our partner teams had a need to build the next generation near real-time processing of Bing.com logs. So the current generation has a couple of implementations. One is based on Apache Storm. The other is based on Microsoft homegrown technology. And when we wanted to do the next generation, Spark came as an obvious choice. But there was one problem with that. The problem was that the existing implementations, the near real-time streaming implementations, as well as the batch processing of the logs, relied on this C# library, and that is implemented in C#. So if we wanted to use Spark to build this application, the next generation application of this application, we had to add support for C# and Spark. And re-implementing that, whatever that business logic encapsulated in that library in any of the languages supported in Spark, Python or Scala or Java is not practical, because this library has been in development and use for several years, and it powers a very critical pipeline. Lots of teams depend on the data that is produced by this library. So to summarize, it's not practical to re-implement. So the only way we can re-implement or implement the next generation platform using Spark is by adding support for C#. So we decided to start this project. So yesterday there was a talk that covered this pipeline in detail, what we have done to process the Bing.com logs using the C# binding. If you're interested, go and check out the video, or you can contact us offline after this talk, or in one of the community forums available for Mobius. So that's kind of a quick background. So once we decided to build Mobius, we realized that there might be other organizations that might be in similar situation like us, that are deeply invested in .NET, but want to try out Spark. And so we decided to kind of broaden the scope, and instead of just implementing the APIs that we need for this one specific application that we wanted to build, the scope was a little broader to support whatever that Spark supports. So basically make the API mirror the standard Spark API, so that anything that can be done in Spark, we wanted to support that in Mobius. So the motivation was to enable organizations to build Spark applications using .NET, and this will allow them to use the existing libraries in Spark as opposed to re-implementing. So now the question that we had is, it makes sense for us, for our business scenario, to have this C# binding for Spark, and also it will help .NET community to build applications in .NET for Spark. But then from Spark point of view, does it make sense to add yet another language binding for Spark? It already has Python R bindings in addition to the Scala and the Java APIs. So does it really need another language binding? I strongly believe the answer is yes. And I wanted to share a couple of data points to explain that reasoning. So the first one is, if you look at the Spark survey results, the last Spark survey results, one of the most important aspects of Spark is the ease of programming. So developers, they either really love a programming language or they really hate it. And before Mobius, there was this gap between the .NET community and the Spark community. So with Mobius, we hope that the developers who are really passionate about .NET but still interested in building Spark applications can leverage what is offered in Mobius. The second thing is, Second data point is the growth of Spark usage in Windows. Look at that huge spike. It's huge. And there's a good chance that a good portion of these users are .NET developers because it's Windows-based. So they'll be more than happy to see something in the language they are familiar with. On top of that, C# is a popular language. There are a couple of ratings available out there that shows the activity in the open source as well as the community engagement around .NET. And above all, the most important thing is that this opens up, having a C# API opens up Spark to the entire .NET ecosystem. For example, F#, there is a passionate community behind F#. And when they think of Scala, they think of F# and not C# at all because of the language constructs and what they support. So when the F# community wanted to build Spark applications, they could use the C# API as it is to build the F#-based Spark application. So there is no change that is needed to the API thanks to .NET. They can just use the existing C# API to build F# applications. But having an idiomatic F# API would be nicer. That is something that we are working on. To summarize, I think it makes sense to have another language binding, and I'm sure it will delight the .NET community. And there you go. The Mobius project was born with the goal of making C# a first-class language for developing Spark applications. So whatever that is supported in Spark, we wanted to support in Mobius. That's still the goal. And currently, it supports RDD APIs, data frame API, and the dstream APIs. And we hope that with contributions from the community, it will grow even beyond this list and support the additional APIs like graph processing, machine learning, et cetera, in Mobius. Let's take a quick look at what a C# application for Spark looks like. So this is what you see in the slide up there. It's a Scala implementation, a familiar word count example. It reads from a text file, and it splits the word, flattens them out, and then adds count 1 to every single word, and then sums them up by the word, and saves the result to a text file in HDFS. If this application is implemented in C#, this is what it would look like. It's exactly line by line. You can compare line by line. It's pretty much the same. The only difference is the bottom half of the slide uses C# conventions. But apart from that, the method names, method signatures, everything is exactly the same. Right? That's a goal. The goal is that somebody should be able to copy Scala code or Java code in Spark, and then copy to Visual Studio, make some modifications, and then they should be able to compile and run. So that's the goal. It's not quite as easy. There are still some changes needed. That's mostly because of differences between C# and Scala. For example, the reduce by key, right? Look at that. So Scala syntax is different than the C# syntax. So there is still some extra work that is needed. It's not as simple as copy, paste, and then build and run. But it's mostly the same. Hopefully, the IDE will help fill in the gaps and then reduce the friction when moving from Scala to C# applications. So there is only one thing that is different between the code in the top of the slide and the bottom, and that is the last map statement in the C# side. So I will cover that in detail, but to kind of give you a brief comment on why it exists. It exists because the data is stored in bytes. So that map converts the bytes to string before it is written to a HDFS file, text file. I'll cover that in detail in one of the later slides. So this is a little more complex example. It's not hello world, but think of it as an hello world for streaming application that reads data from Kafka and then processes the messages in Kafka. So the first thing that happens is initializing the streaming context and the checkpoint. and then it creates a direct stream from Kafka. Again, the method signature, the method name, everything is the same. The parameters, what you want to pass, everything is same as that of Scala implementation. And once the stream is created, then the transformations are defined. So here, the message format is a CSV file, CSV format, timestamp, log level, and log message. And what we want to do here is to do an aggregation within a time window based on the log level. And then finally, the computed aggregation is saved to a text file for every batch, and then the processing is started. So as you can see, if you have seen Scala code, it would look exactly the same. There is no difference at all. So that's hello world for Kafka in C#. To step back, this is what the overall the stack looks like. So we have the application code that is written in C#, and that takes a dependency on the C# API. The green box is the Mobius. And then Mobius itself takes dependency on the Scala and Java public APIs, as well as some PySpark implementations. So essentially, it depends on what is available in Spark. So if something is available in Spark, we just leverage that. There is no duplicate implementation or anything. It's just calling into the Spark API to do what is already implemented. No reinvention of wheel here. Let's take a look at how the workflow to develop and launch a Mobius application. It's a C# code, so it is developed in an IDE like Visual Studio. So the first thing to do after the project is created is to add a reference to the Mobius binaries. So Mobius binaries are published to NuGet, and if you're not familiar with NuGet, it's think of it as like a Maven repository. And once the reference is added, then additional references are added. If you have a custom DLL that you want to use in your application, that needs to be added as a reference too. And then the application is developed within Visual Studio. So it's developed, debugged, and tested within Visual Studio. And then finally, the driver program, the exe, is built. And this is what that gets deployed. So in Scala world, you would build a jar file that gets deployed and then executed in Spark. So in Mobius, the equivalent is the executable. So that gets executed in Spark. So once it is there, the executable has to be copied over to an existing Spark client. So it's a client, it's a machine with Spark bits, and that can be used to submit jobs to a Spark cluster. So it has a Spark bits already downloaded, and Mobius is downloaded as well. The release is available in GitHub, so it's downloaded. And then finally, it's the Mobius driver application is copied over and then run. So to run the Mobius application, there are scripts available in Mobius. So Spark CLR Summit, Sparkler Summit, that's what we call it. There's a Linux flavor and a Windows flavor that is used to run the Mobius application. And these scripts take the exact same parameters that Spark Summit takes. All the configuration parameters, setting the driver memory and the number of cores and specifying the master configuration, everything is exactly the same. It just passed through to Spark Summit eventually. The only extra parameter that's passed to these scripts is the executable name, the one that's built on the left side. So it's as simple as that. If you're familiar with Spark Summit, then probably you already know how to use the Sparkler Summit scripts with the extra executable argument that you pass. So now let's take a look at how Mobius and Spark interact. So this is probably a familiar setup to you if you're familiar with Spark. So on the driver side, there is Spark context, and in the worker side, Spark executor, everything running happily within JVMs. But Mobius is written in C#, right? Your driver application as well as the worker implementation is in C#, and that doesn't run inside JVM. That needs CLR to run. So what happens is that in the case of Mobius, the entry point is the Mobius executable, and that is launched inside CLR. And whatever that happens within the C# driver, the application that you develop, that gets mirrored in the JVM Spark context as if somebody has written native Scala or Java Spark applications. So instead of user writing all these commands, transformations and actions in Java or Scala, essentially what this is implemented in C#, and that gets mirrored in the JVM in the driver side. In the worker side, it's kind of similar. If there is any C# operation that has to be executed, it needs CLR to run. And in that case, the C# worker.exe is launched in the workers, and the data and the actual functionality transformations that need to execute in C# side get sent over to CLR. So together, CLR and JVM help complete or run the job. So as you can see, CLR, yes.
Can this run on a Spark cluster that's Linux?
Yes, that's the next point. Thank you. So I didn't set it up. It's just a natural question that came up. So given the setup, as long as CLR can be launched, this can work in any Spark cluster. Right? So Spark in Linux or Windows doesn't matter. And we have tested within standalone mode and yarn mode. We have not played with it, but we have not played with Mesos, but it should work, or it may need some minor things, minor validation, or if there is any parameter support that we need to do. But other than that, it should just work. So that's a good segue to talk about Mobius in Linux. So how does Mobius work in Linux? CLR is built originally for Windows, so it works fine, no questions there. In Linux, we need Mono. Mono is the open source implementation of .NET framework, and to execute C# in Mono, in Linux, Mono is needed. And with Mobius, the continuous integration runs both in Windows and Linux. And for the Linux continuous integration, we use Ubuntu, but users have reported using Mobius in Ubuntu, CentOS, and OS X, giving a broad coverage across different Linux distributions. And Mobius is also cloud ready. You can use Mobius in your favorite cloud. It could be Azure H3 Insight Spark cluster, which is Linux based. Also the Amazon Web Services EMR Spark cluster. Again, the only thing that you have to do in addition is to install Mono, and then you're good to go. Mobius will just work. Let's look at some project information. It's an open source project, so contributions are welcome. Any contribution is valuable, like in any open source project. It could be documentation updates, it could be bug fixes, it could be adding extra samples. Anything is fine. And there are a couple of ways to engage with the community, rest of the Sparkler Mobius community. So the Stack Overflow tag is still Sparkler, because Sparkler was the old name of Mobius project, so it's still retained. But it's a good way to engage with the community. And there is also a Gitter chat room available, and folks seem to use it a lot when they want to interact with the community. And then there is also Twitter and GitHub issues. These are the common ways to interact with the rest of the Mobius community. Looking at the releases, we have had two releases so far. One is for 1.5.2, the other is 1.6.1. The next release is going to be the major release. The next major release is going to be 2.0 when 2.0 Spark comes out. But then there might be other minor releases in 1.6 branch as we do the bug fixes and then making updates to the code base. But the major one is going to be right after Spark 2.0 is out. There are a couple of important work items that I wanted to call out, and one is the support for interactive scenarios, integration with Zeppelin and Jupyter, and exploration of ML scenarios. I mentioned that currently it supports, Mobius supports 3 different sets of APIs, and we would love to add support for machine learning and graph processing APIs. Idiomatic F# API has come up a couple of times, and several people expressed interest in having such an API. As I said, F# community is very, very passionate on F#, and I was delighted to see their interest in Mobius, especially in having F# based F# supported in Mobius. So these are the things that we hope will happen in the next couple of months. So we have 5 minutes left. Let me try to talk about what is under the hood quickly, reserving a couple of minutes for the questions in the end. So I'm going to go very fast. this slide is created for offline reading, so apologies if you find this, the next couple of slides go very fast. So C# RDD is an important thing to understand when it comes to Mobius. Basically, the C# RDD is an extension of Python RDD. Right? If you're familiar with Spark implementation, it has different types of RDDs, Hadoop RDD, Kafka RDDs, Python RDDs. C# RDD is yet another type of RDD, and that controls or determines or it encapsulates the logic to spin off an external process and the data get processed and get it back. So all of this is already implemented in Python. We are just inheriting from that Python implementation to do the work. And the point to note here is that if there is no C# custom defined functionality, for example, you're just loading from a text file and doing a count of lines, right? There is no C# custom functionality involved. And this execution, even though you write the code in C#, right, the driver code, in the execution side, in the worker side, there is no CLR involved because there is no C# functionality, right? So the execution is purely JVM based. When you think about C# RDD, think of it as RDD of byte arrays, and the data gets sent between JVM and CLR, and transformations are pipelined as much as possible. If you have 3 map steps that you want to do, each of them do not have to send data across to CLR for every single time, right? So they are pipelined together within a stage, and then they get executed in one shot in the C# side. Think of it as an optimization. And the driver side interop, the first thing that happens is you launch the script, Sparkler Summit, and then that launches the JVM. It launches the C# runner and the backend. If you're familiar with R implementation in Spark, it has something called R backend. So this is similar. It acts as the proxy between JVM and CLR, and then C# runner also launches the C# driver, which eventually kind of manages the objects in the C# side, and that gets mirrored in the JVM side. So whatever that happens gets replicated, and C# RDD, as I mentioned, it's there. Anytime you do the pipelining of RDD in the C# side, that kind of is reflected in JVM as a C# RDD. And as I mentioned, C# RDD knows how to spin off a process in the CLR and then get the data processed. Worker side interop, so it's an RDD, so compute method is called by Spark, and when that is called, the external process is launched, and then that process reads data and also the operations that need to be executed, and then they get executed, and then the data is written back. So worker optimization, we have 2 types of worker configurations available. One is multi-threaded. So instead of spinning off the CLR process every single time that you want to execute something, it's multi-threaded so that this process stays running until the job, or the lifetime of the job, and then threads are used to run the operations. The other thing is a multi-proc. So this is kind of new, and we are still evaluating how the benefits that it brings. Performance considerations, there is some serialization, deserialization involved if you use C# operators, so you need to be aware of that. But the good thing is pipelining happens, so unnecessary serialization and deserialization is avoided. At the same time, the other thing to notice, if you don't have any custom C# function, for example, if you use the standard data frame API, read from Cassandra, read from SQL table, or read from Hive, and if you're doing this standard data frame API, you write everything in C#. But if there is no C# user-defined functions, the execution is purely JVM based, so the performance will be as good as the native Scala-based implementation. So that's it. So Mobius is production ready and cloud ready. So if you are a .NET developer, please use it, and better yet, contribute if you can. F#, C#, any contribution is great, and then contact us if you have any feedback or if you have any questions. Thank you.
So we've got a couple minutes for questions, so raise your hand and I'll run it over to you.
So very nice to see this. One question was, you were showing a diagram where you had a Visual Studio building a binary, and you said it isn't .exe, and then that gets shipped over to the cluster, and let's say it's a Linux cluster.
Yes.
So are you just extracting like the .NET assembly from that exe?
It's just exe. The executable, the exe is run, right? We don't extract anything.
Okay.
So I think you're talking about this slide. Sorry.
What's throwing me a little bit here is
this one, right?
I expect
So exe.
.exe to be a Windows.exe and not a Linux, library or something like that.
It's a standard executable that gets built when you build C# code. Yeah, mono runs it.
Oh, okay. Got it. Okay, thank you.
Thank you.
Cool. Any other questions? Just please raise your hand. Oh, there you go. Sorry. Go for it.
So my questions are based on around performance. So with the CLR, with the .NET CLR, are you still able to take advantage of the optimizations that you get from Catalyst? And my second follow-up on the .NET side, have you done any or tested using sort of the .NET's async, await, or the task library, not to be confused with Spark task, but the task framework as an optimization? I'm just curious to see what your feedback was on that.
So the first question, the Catalyst optimization, everything kicks in if you don't have any custom C# UDF in your implementation. Right? If you're reading from Cassandra, doing some aggregates and doing some filtering, all those things, standard data frame APIs, no UDFs, you're not registering any UDFs, you're fine, right? Catalyst optimization, everything kicks in. But then, anytime you have the C# UDF that is registered, then the optimizations, you won't get the best out of it, right? So some of it may be applied, but not everything, because the optimizer will not know what is done for the UDF. And that is true. Whatever, if you have seen some performance-related discussion or presentations on Python with Spark, so the same things, all the benefits as well as disadvantages apply to this implementation. So even though I did not go into detail, so anything you have seen with Python, think of it as relevant to here. The second one, we have not looked into task library and stuff. But again, that can be the third optimization option to consider if that's going to benefit. Thank you.
So how much of your code changed between version 1.6 and 2.0? I mean, going forward, how big a job have you taken on for yourselves? Good
question. Great question, in fact. So there's not much change, surprisingly. So there were some changes that we had to do in the worker side. It's kind of transparent to the user. If you have developed an application, the application doesn't change because of the API. But then in the worker side, what gets passed to the worker, that changed, especially because of the optimizations. And so we had to make some changes in the worker side. It's transparent to the users, though. But it's not much, surprisingly. And we had to do that even between 1.5 and 1.6. So it's not just the change between 1.6 and 2.0. Even from 1.5 to 1.6, we had to make some changes in the worker because we are relying on some of the internal implementation details. So Spark can change it any time. And whenever they change it, we have to adapt to that. It's not a public API. So yeah, good question.
Cool. That's it for time. So thanks very much, everybody.
Thank you. Okay.